Hello friends, today we are going to study ERTMS bar ETCS level 2, which is one of the most important and widely implemented levels of the European train control system. Level 2 represents a major technological shift from conventional signaling to modern radio-based train control. Understanding this level is essential for everyone working in advanced railway signaling and high-speed rail operations. ETCS level 2 is the second operating level of the ERTMS bar ETCS system. Unlike level 1, which relies mainly on intermittent communication through Balises, level 2 is based on continuous transmission of information from track to train. This means that the onboard equipment always has real-time and update information about the condition of the track ahead. As a result, level 2 provides higher safety, better operational efficiency, higher permissible speeds, and more reliable train control. Continuous radio communication. The key features of level 2 is continuous radio communication. At this level, all important information required for train operation is sent continuously from the track side to the train through a central control unit called the RBC, a radio block control. The RBC is connected with the interlocking system, which safely sets and locks the train routes. So the overall concept is interlocking decides the route, RBC receives this information, RBC communicates it to the train in real time. This creates a fully supervised and centralized control system. A role of GSM-R. Communication between the train and RBC is made possible through the GSM-R network, which is a railway dedicated mobile communication system. An important point is that communication is bidirectional. This means the train receives information from RBC and the train also sends information back to the RBC. Because of this continuous radio link, controlled Balises are no longer required in level 2. Only fixed Balises are used, which we will discuss next. Function of fixed Balises. Even in level 2, Balises are not completely eliminated. However, their role becomes very limited. Fixed Balises are used only for two main purposes: to determine the exact position of the train and to provide static speed profile information. Precise location of the train is calculated using Balises and onboard odometry equipment. So, Balises act as reference points rather than as primary signal transmitters. Movement authority. One of the most important concepts in level 2 is the movement authority, commonly called MA. The RBC sends the movement authority to the train. This MA contains geographical data of the route, distance to the next obstacle, status of track circuits or blocks, limits up to which the train is allowed to move safely. The obstacle may be another train ahead, an occupied block, a stop point, or any restriction on the track. Based on this MA, the train knows exactly how far and how fast it can proceed. Cab signaling concept. A major change introduced in level 2 is the traditional line-side signals are no longer required. All driving information is directly shown inside the cab on a screen called DMI, Driver Machine Interface. The driver receives permitted speed, target distance, braking curves, and movement authority information. So instead of looking outside at signals, the driver follows the instructions displayed inside the locomotive. This is known as cab signaling. Train protection mechanism. Safety supervision in level 2 is fully automatic. If the driver does not follow the instructions shown on the DMI, first the system gives a warning. If there is still no response, the service brake is applied. In critical situation, the system applies the emergency brake. This ensures that human error is minimized. The train never crosses the safe limit. Accidents due to signal passing at a danger are prevented. Thus, level 2 provides a very high level of automatic protection. Train position detection. Even though communication is radio-based, train detection on trackside is still required. In level 2, track circuit or axle counters continue to be used. Odometry equipment on train measures speed and distance. Balises help in correcting position errors. The odometry system continuously monitors train speed, compare it with the permitted speed, and calculate safe braking curve. This combination ensures accurate and reliable train localization. Advantages of ETCS level 2. Compared to level 1, ETCS level 2 offers many advantages. Continuous train control instead of intermittent control. Instant update on any change in track conditions. Higher operational speeds. Better punctuality. Higher safety levels. Reduced dependency on trackside signals. Overall, level 2 gradually modernizes railway operations. Limitations. However, level 2 still has some limitations. The main limitation is that train separation is still dependent on track circuits or axle counters. Because of this, the minimum distance between two trains cannot be drastically reduced. Also, level 2 requires high reliable GSM-R communication network and robust RBC and interlocking systems. These infrastructure requirements make implementation complex and costly. To conclude, ERTMS bar ETCS level 2 represents a major step towards modern, high-speed and safe railway signaling. It replaces conventional signals with radio-based cab signaling and provides continuous supervision of trains. Although it still relies on trackside detection systems, it significantly improves safety, speed and operational efficiency. Understanding level 2 is essential before moving to more advanced concepts like ETCS level 3, which aims for moving block operation. Okay, thank you.